Modus Ponens. What is it? In this video, you will learn what Modus Ponens is, and you'll compare Modus Ponens to Modus Tollens. They have a conditional premise in common, so they're easily confused, so we'll go over both of those. We're going to start with some of the words you should understand before you even get to Modus Ponens. Let's get started. A Modus Ponens is an argument form. It's a form, it's a formula. I don't know if you remember from mathematics this formula y equals mx plus b, but if you remember this, then you remember the slope-intercept form. If you make m the rise over the run and you plot whatever you plug into these onto that Cartesian xy coordinates, then this formula will get you a specific geometric shape. Okay, maybe that's too much, but it's an analogy. The y equals mx plus b is a formula that you can plug information into, and from it you can create different shapes on a graph. Modus Ponens is a formula that if you plug in certain propositions, you can generate a full argument that will be valid. Now we'll slowly get there. This is Modus Ponens, by the way, but what is it? Modus Ponens is an argument form. It's a formula. Think about a cookie cutter. If you have a cookie cutter that is shaped like a heart, then you can use that cookie cutter to make heart-shaped almost anything. Take glue and put a bunch of glue, and then take that heart-shaped cookie cutter and put it in there, and you can extract a heart-shaped glue thing. You can make a heart-shaped cookie, you can make a heart-shaped lots of things. Concrete, if you just do it at the right time. This formula allows you to plug different things in and create different things with it, different arguments. Okay, let's keep going. Modus Ponens is a valid argument form. This will always be a valid argument. Even if you point something ridiculous to represent P, or even if you take something ridiculous to be represented by Q, whatever you plug in, it will always be a valid argument. Just like if you take concrete and you take a cookie cutter and you make a cookie-shaped concrete thing, it's like ridiculous. What are you gonna do with that? But it'll always be heart-shaped if you use a heart-shaped cookie cutter. This is a valid argument form, so your argument will always be valid, even if your conclusion is false, even if in the conditional premise your antecedent and consequent have nothing to do with each other. This is Modus Ponens, and Modus Ponens is a valid argument form. In deduction, in deductive reasoning, what you're doing here is deducing something specific from more general things. What you're doing here is saying if P then Q, and you're also saying P, and from that we are deducing Q. We are affirming Q by affirming P with this assumption that if P then Q. There's also a conditional statement that's one of the two premises in the Modus Ponens. If P then Q is a conditional statement, we're learning a relationship between the proposition P and the proposition Q. And if that condition is correct, meaning the Q is guaranteed on the condition of P, then if we add P, then we are guaranteed Q, which is how conditional statements work. So Modus Ponens involves a conditional statement, and there's propositions. There's lots of propositions in here. If P then Q is a proposition, it's a statement which could be true or false. Q is a proposition. Q on its own is a statement which could be true or false. Not both, not neither. P is a proposition. It's a statement which can be true or false, not both, not neither. And this definition of proposition is basically just recounting the law of excluded middle, which is assumed by logicians. And Modus ponens is also logic, deductive logic, that uses a conditional statement in one of the two premises that, when you put it together, give you a valid argument form through which you can deduce the consequent in your conditional statement. Okay, so backing up here, if you don't understand some of these background terms, then that could be why you're failing to fully understand modus ponens. This is modus ponens, but compare it to something that looks really similar, modus tollens. In modus ponens, one of your two premises says if P, then Q, and that's a conditional. On the condition of P, then you will be guaranteed Q. Modus tollens and modus ponens both have this conditional idea within the premises of the argument, except whereas modus ponens affirms P and then deduces Q, modus tollens denies Q, and then the conclusion is the denial of P. So these are very different. Let's have an example of modus ponens. So for this example, we're going to need to know what P and Q stand for so that we can put it in something like English. And for both of these, I want to use the same so that you can easily compare. Let's let P represent this proposition, it is raining. And let's let Q represent this proposition, you should take an umbrella. You should take an umbrella is a proposition. It's a statement which could be true or false and not both and not neither. So is it is raining. Either it's raining or it's not raining. It's not both raining and not raining. It's not neither raining or not raining in a particular position, in a particular part of the world, from a particular perspective, with somebody's definition of what amount of rain needs to be to constitute raining as opposed to drizzling. It's either raining or it's not. P is either true or false. Q is either true or false. Now plug it in here. This premise would say, if it is raining, then you should take an umbrella. This premise says it is raining. And the conclusion is that you should take an umbrella. And that is always going to be a valid argument because you're correctly plugging in propositions into the places at the correct appropriate place, like you didn't switch Q and P, for example. If it is raining, you should take an umbrella. It is raining, therefore you should take an umbrella. That's valid. Compare. If it's raining, you should take an umbrella. It's not raining, therefore you should not take an umbrella. It's not the case that you should take an umbrella. Modus tollens is going to deny the antecedent by denying the consequent, whereas in modus ponens, you are affirming the consequent by affirming the antecedent. So that's how these two are different. Even though they share a structure, they have a conditional statement, and we're doing one thing with one of the two parts of the conditional compound statement, and we are deducing the other part from it.